everybody. Today we're going to be talking about our Team Teach chapters 4 and 5. We're going to be going over transformations, and we're also going to be learning about lines of symmetry and some other things. So we'll go ahead and jump on to it. Alrighty, so Cheyenne, what is a common mistake people make when understanding rotation and reflection as a transformation?
Well, the most common mistake that you will see is that when people are rotating the figure, they automatically think that it is a reflection of the original figure because it is across a line. But if you look at the bottom right corner of the trapezoid, that is where it is rotated on. A reflection is a mirror image of the original figure. So that means that the figure that you are looking at is now a reflection of the pink trapezoid.
Alrighty, thank you so much.
You're welcome.
Amanda, what is the motion presented?
Okay, so the motion that was presented for the students in question 1 was this action right here. We know that it did a rotation of 180 degrees. And we know that because if it did 360, it would come back to its original position. So it did a rotation of 180.
Thank you. That was great.
Thank you.
Jerry. Liz and Jeff were asked to reflect the pattern block figure shown on the left over the horizontal line through the center of the square.
Yes, they were asked to do that, and they did a reflection, but they only did a 180 degrees rotation, not a full reflection of the figure.
All right, thank you.
You're welcome. Oh, Cheyenne,
right.
Identify the symmetry of these shapes and explain why.
Well, the symmetries that we are going to be looking at are one line of symmetry, rotational symmetry, and reflection symmetry. The figures that we are given is the trapezoid, pentagon, triangle, circle, rectangle, and an arrow. The trapezoid and the arrow represent one line of symmetry because they only reflect over one line. A rotational symmetry, the circle and the pentagon would be examples of, is wherever you put the line of symmetry on those figures, it'll continue looking the same on each side. Reflection symmetry is when you have a shape that looks the same on each side when you put the line of symmetry in. The triangle has one, well also it has multiple, but in this case we're showing one. The rectangle has two lines of symmetry that it looks the same on both sides. And that will be it.
All right, thank you.
Amanda, what should the horizontal reflection look like? Okay, so that's a good question. So we know that this is the figure, and we saw previously that it did a 180-degree rotation. So what it needs to do is it needs to reflect it. And we're doing a horizontal line. And see this triangle? This triangle has to be on the same side because it's a mirror image. It's like when you look into a body of water, like a pond or the ocean, you see your reflection, and it's the same thing for the shape.
All right, thank you.
You're welcome. All right, Cheyenne, can you create a translation using the given figure?
Well, if we are looking at the rhombus on the coordinate plane, you will see that it is of the position -6 at the top point and -8 4 on the bottom point, or the left side. So when we move it up 3, the ending points will be -6 9 on the top and -8 7 on the left.
Alrighty.
My bad. And then when you move it over 2, it will be at -8. Well, in this case, it'll be -10 7.
Alrighty. Thank you so much.
All right, you're welcome.
Sharon, what type of symmetry would this image have, and how many lines of symmetry?
Well, this shape is an example of rotational symmetry. Why? Because when you do the lines all the way around the symmetry, it'll continue looking the same. This figure has 6 lines of symmetry represented.
All right, thank you.
You're welcome.
Amanda, we will want to figure out the angle
Yes, so
in question 5.
Yeah, so this angle right here is going to be the problem that we're going to be trying to solve. So this is kind of like an introduction to question 5. So we're going to be looking at the angle that's inside the triangle and the pentagon. All right, Jerry. Can you
How
tell
would
us?
you find the interior points for the penta for question 5?
This is how you find the interior point for question 5. You take the number of points on the pentagon, which is 5, and there is 360 degrees in the circle. So you take 360 degrees, divide by 5, which is 72 degrees. That's what each angle should be, 72 degrees.
All right, thank you.
Amanda, what number would you use to divide with 360 degrees to solve the measurements?
Okay, so like you previously discussed, we're going to look at the penta or the pentagon, and we're going to look at the angle inside of it. And so, like you said, we're going to take the number of points or the number of sides on the penta, and we're going to use that to divide by. And so that's why you would use the number 5.
All right, thank you.
You're welcome. Jerry, how would you solve the interior angle of a triangle PQR?
You take the triangle and you put it into a circle, and the circle is 360 degrees, and the triangle is only 120 degrees. So you take, and there's 3 points on the triangle. So you take 360 divided by 3, and you get 120 degrees.
Thank you so much.
You're welcome. Amanda, what does the number 3 represent in the equation?
Okay, so right now in this equation, we're looking at this triangle, and we're looking at the angle inside the triangle. So the number 3, like you said, is going to be the number of points or sides. Again, so we take 360 because it's in a circle, and we divide it by 3, and that gives us 120 degrees.
Thank you.
You're welcome.
All right, Jerry, can you explain this step of the process?
Yes, you take the equation you got from the pentagon and you double it to get it to 144 degrees. And then you take the equation you got from the triangle PQR, which is 120 degrees right there.
All right, thank you.
All right, Jerry, will you explain how to solve the angle for NOQ?
Yes, you take the pentagon, which is PENTA, multiply it by 2, minus the triangle PQR, and you get 24 degrees. And here it shows down below the numbers of that, which is 72 degrees times 2 minus 120 degrees, which equals 24 degrees. And that is the angle of NOQ.
Thank you so much.
Cheyenne, is triangle QVT congruent to triangle SVT?
Well, yes, triangle QVT is congruent to SVT because angle V is 90 degrees on both angles because it falls on a line M, which is 180 degrees. When you're looking at angle T, it is an acute angle on both triangles because it is less than 90 degrees. When this triangle is flipped over the line, the angles will line up at the same point. So Q will be S, P will still be P, and T will still be T, represented in both triangles.
Thank you.
You're welcome. Amanda, how would you solve the height of the cliff?
Okay, so that's a good question. So we know from this picture that this girl right here, she's holding up a ruler and she's putting it at the cliff. And she's saying from the top point to the bottom point. And she needs to know how she could find the height of the cliff. So we know that she has a 2-foot ruler, and the inches apart from where she sees it from her point of view is at 1.5 inches from the top to the bottom of the cliff. And we're going to write the equation as so, and we know that she is 1/4 of a mile away from the cliff. And we need to solve for the height of the cliff. So we're going to kind of do a cross multiplication problem, but we need to find out a few things first. We need to find out if we can get all these down, the inches and the miles, into feet, because we have to have the same unit. So we know that 1/4 of a mile will equal out 1,320 feet. And then if we want the inches into feet as well, you need to divide it by 12 because 12 inches are in a foot. And that gives you 0.125. And so when you write it as 0.125 times 1,320, you get 165. Then we're going to divide that because of the ruler. And that will come to 82.5, but we're going to go ahead and round that, and it's going to be 83 feet.
All right, thank you for explaining that to me. I understand a lot better now.
Well, good. Thank you.
You're welcome.
Explain how to solve this problem.
All right, Amanda, as in the previous problem, the young lady is holding up the ruler with a 1.5 inch view of the cliff from top to bottom. And she is 1/4 mile away from the cliff. And 1/4 mile, as we know, is 1,320 feet. So you take the inches that she's using, which is 1.5 inches, divide it by 12 inches, and then you get 1.25 inches, or 0.125 inches. And then you take the 0.125 inches of a foot times the 1,320 feet, divided by 2 feet, which equals 82.5 feet. And they told us to round it up in the problem, so which is 83 feet.
Thank you so
From
much.
top to bottom.
I can understand that perspective now. Thank you.
You're welcome. All right. Cheyenne, what was the height of the cliff?
Well, if we know that Jenny, the girl in the picture, is 1/4 of a mile away from the cliff, and she's holding a ruler out 2 feet in front of her, and the top and the bottom of the cliff is separated by 6.5 inches instead of 1.5 like the previous problems, we know that 1/4 of a mile is 1,320 feet due to the fact that we take 5,280 divided by 4, we'll get 1,320 feet. 6.5 divided by 12 will give you 0.542. And when we put it into an equation, it'll look like 0.542 feet over 2 feet equals the height of the cliff over 1,320 feet. So when we multiply 1,320 feet to both sides, it'll leave us with the height of the cliff on the left equals 0.254 feet times 1,320 feet divided by 2. So when you multiply the top two numbers, you will get 715.44 feet. And when you divide that by 2, you will get 357.72 feet. And when you round it up, you will get 358 feet for the height of that cliff.
All right, thank you. That was
You're
great.
welcome.
All right, guys, that is the end of our video. We hope that you learned some new keys and hints to help you solve those problems, and we hope you have a great day. Thank you so much for watching.
Bye.
Bye.